This is Dr. V. Anita Rani, Associate Professor of Chemistry from Institute of Aeronautical Engineering. In the previous class, we have discussed about natural resources, classification of natural resources, so that are living and non-living resources, renewable and non-renewable resources. Today, we are going to discuss about water resources. So, in the previous class, what we have discussed, living and non-living resources. What are the living resources? Living resources are, so we can take forest, croplands, animals, living resources. Non-living resources means soil, water, so all that are non-living resources. So what we are going to discuss, water resources. Water resources. So when we take the types of natural resources, so we can discuss water resources, soil resources means land resources, and energy resources. So what we are going to discuss today is in water resources, use and over-utilization of surface and groundwater, floods and droughts, dams benefits and problems. Use and over-utilization of surface and groundwater, floods and droughts, dams benefits and problems. So what are water resources means? We know water is it is very essential to our life, to live on the earth. For the plants, animals and human beings, water is essential. So water is an indispensable natural resources on this earth, on which all life depends. About 97% of the earth's surface it is covered by water, and most of the animals and plants have 60 to 65% water in their body. So how much percentage of water is covered in earth is 97%. So all the water is abundant on this earth, but it is very precious. Out of all the total water reserves of the world, about 97% is salt water and only 3% is readily available to us in the form of groundwater and surface water. Only 3% is available in the form of groundwater and surface water. So even this small fraction of fresh water is not available to us, as most of it is in like polar ice caps. Polar ice caps, and just 0.003% it is available to us in the form of groundwater and surface water. So overuse of groundwater, for example, if you are using groundwater more, overuse of groundwater for drinking purpose or irrigation, for field cultivation of the crops and domestic purpose, here what happens, depletion of the groundwater, it takes place, depletion of the groundwater, it leads to the lowering of water table, and also drying of the wells. So pollution of many of the groundwater aquifers have made many of these wells unfit for consumption. So when we are using this groundwater for irrigation purpose and domestic purpose, so this groundwater it is polluting. The groundwater is polluting, and it becomes now unfit for consumption. So rivers and streams have long been used for discharging the waste. Now what people are doing, they're throwing the waste in the rivers. And lakes. Okay. Now water is polluted. So most of the civilizations have grown and flourished on the banks of the rivers, but unfortunately, growth in turn has been responsible for pollution of these rivers. So as the population is increasing, so the needs of the people also it is increasing, and they are polluting the water. They are throwing the waste in the rivers and lakes. So as per the United Nations estimates in 2002, at least 101 billion people do not even have safe drinking water. 101 billion people, they do not have safe drinking water, and 2.4 billion, they do not have sanitation facilities. So they do not have water for for sanitation facilities also, for washing, cooking and also. So they do not have the water. So increasing population and expanding development would further increase the demands of water. So as the population is increasing, so demand for the water also increasing. But how people are using the water is they are not using properly. So that leads to the pollution. So it is estimated now by 2024, two-thirds of the total world pollution, two-thirds of the world pollution, so it will be suffering from water shortage. It will be suffering from water shortage by 2024 because we are not utilizing water properly. So our future generation, so they do not get the enough water to utilize, and there will be scarcity of water will be there. So water, it is a unique resource. It is a unique resource. So it is characterized by certain unique features which makes it marvelous resource. It exists as a liquid over a wide range of temperature. So when it will be in the form of liquid, the temperature will be 0 to 100 degrees centigrade. So it has the highest specific heat, due to which it warms up and cools down very slowly without causing shocks of temperature, jerks to aquatic life. See, when we take like rivers, lakes, seas, we know aquatic life means the fishes will be there, okay, and some other organisms will be there living in the river. But as the water is changing its phase also, so here we can tell that because of this water is having high specific heat, that does not here sometimes it may affect aquatic life also, but because of it is having high specific heat, it warms up and cools down very slowly. It warms up and it cools down very slowly without causing any shocks to the aquatic life. It has highest latent heat of vaporization, hence it takes a huge amount of energy for getting vaporized. Okay, what is latent heat of vaporization? Water vaporization, 587 kilocalories per minute. Okay, so it takes a huge amount of energy for getting vaporized. So the liquid form of the water, it will vaporize. So it will convert into water vapor. So that's why it produces a cooling effect as it evaporates. So first of all, we have to know what is hydrological cycle. So the water we use keep on cycling endlessly through the environment, which we call it as a hydrological cycle. So the water from various moist surfaces evaporates. Okay, so the water from the lakes, rivers, seas, the water evaporates and falls again on the earth in the form of rain or snow. So in some countries it will fall in the form of snow. In some countries it will fall in the form of the droplets, that is rain, and passes through the living organisms and ultimately returns to the oceans. Ultimately, again the water, it returns to the oceans. So the cycle, it will go like, okay. So the water evaporates, okay, from the sources of water like a river, lakes. Again, it forms in the form of clouds. Again, now when the clouds are cooling, okay, then again the water, it comes up in the form of the rain. So every year about 104-inch thick layer of water evaporates from the oceans, and more than 90% of which returns to the oceans through the hydrological cycle. So solar energy drives the water cycle by evaporating it from various water bodies, which subsequently returns through rainfall or snow. So we know that how water evaporates in the form of here when a temperature, when heat is there, when more temperature is there, in that hot temperature, then the water evaporates from the water bodies. Okay, it will be forming in the form of clouds, and when the cooling of the clouds is taking place, again we get the rain. So plants also, it plays very important role by absorbing the groundwater from the soil. So plants also, it will absorb the groundwater from the soil and releasing it into the atmosphere by the process of transpiration. The plants also, it is evaporating the water. Okay, so global distribution of water resources is quite uneven depending upon several geographic factors. So tropical rainforest, for example, tropical rainforest that receives maximum rainfall. Okay, so here in India, according to this temperature, our weather conditions, so our here the rainy season will be around like a 3 months. So there will be in tropical rainforest there will be maximum rainfall around in one whole year also the rainfall will be there. One year also rainfall will be there. Okay, so taking some other countries like South Africa, okay, where rainfall will be very less. Rainfall will be very less. So depending upon the weather conditions, so the hydrological cycle will be there. So we can see in this diagram where we can see the transpiration from the plants, and it is in the form of the clouds. We can see here in the form of the clouds, and again here we can see condensation of the clouds is taking place. Condensation of the clouds. So condensation of the clouds. When condensation of the clouds is taking place, here we can see the rainfall. We can see the rainfall. So this is the water cycle. So first from the water bodies, for example, this is the river. From the water bodies, so the water is evaporation. So then it will be forming in the form of the clouds. Then by condensation, here where we are getting after condensation, we get the precipitation, nothing but rainfall. So after rainfall again, so where that rain goes, again it goes to the water bodies, again it goes to the the plants absorb the plants absorbs the rain, and also directly the water it goes to the water bodies. Again the cycle will be repeating. So due to the solar heat, already we know the water evaporates or water is lost to the atmosphere as vapor from the seas, which is then precipitated back in the form of the rain or snow. Okay, the evaporation and precipitation, it continues forever. In the arrow mark in this diagram we can see, so evaporation, and we can see condensation. Okay, then again the precipitation. Okay, so when evaporation of the water is taking place, that is forming in the form of clouds. Okay, so again when condensation of here the water is taking place, again precipitation takes place, nothing but a rainfall will be there. Okay, so the evaporation and precipitation continues forever, as thereby balance is maintained between the two. So this process is known as hydrological cycle. So solar radiation and Earth's gravitational pull are the main forces of water cycle. So solar radiation, okay, means the sun's energy, and Earth gravitational pull are the main driving forces of water cycle. So what we can see here, evaporation, condensation, precipitation. So first evaporation of the water is taking place from the water bodies, then condensation of the water takes place, that is in the form of the clouds, then precipitation, nothing but the rainfall. Okay, these are the main process involved in water cycle. So these processes are here we can see in this diagram, that is evaporation, condensation and precipitation. So water use and over exploitation, okay, due to its unique properties of water of multiple uses for all living organisms, okay, it is essential for us. So uptake of nutrients and their distribution in the body, regulation of temperature and removal of waste are all mediated through water. Okay, so if we are not drinking water, all these are not happening. Okay, so we will eat food and we are not drinking water, means nothing, no functioning will be there in the body. Okay, digestion or whatever, removing the waste, it does not occur in the body. So uptake of nutrients, their distribution in the body, regulation of temperature and removal of waste, all are mediated through water only. So human beings depend on water for almost every developmental activity. So we Human beings, we will depend on water. Without water, without air, we cannot live. So water, it is used mainly for drinking, irrigation and transportation, washing and waste disposal, that is for the industries. And it is used as a coolant for thermal power plants. So it is used for drinking, irrigation, that is cultivation of the crops, and for washing purpose and waste disposal for industries, and it is used as a coolant for thermal power plants. And water shapes the earth's surface and regulates our climate. So water, it is used by humans in two types, water withdrawal and water consumption. So water withdrawal means taking water from the groundwater or surface water. Means we will take the water from the groundwater or surface water resource. Water consumption means the water which is taken up but not returned for reuse. The water which is taken up but it is not returned for reuse. So on a global average, 70% of the water withdrawn is used for agriculture. So 70% of water we are using for agriculture. In India, we use 93% of water in agricultural sector, while in a country like Kuwait, which is water poor country, only 4%, only 4% it is used in industry, which is again varies from high 70% in European countries. So in developed countries, so they are using more water. In non-developed countries, okay, underdeveloping countries, they will use less water. So in USA, an average family consumes more than 1000 cubic meter of water per year. So which is many times more than in most developing countries. So when we compare India and USA, other countries, in USA, so that country, it is utilizing more water comparing to the other countries. So here we can take the freshwater resources. Freshwater resources are two types: surface water, underground water. So freshwater, so already I told 97% it is salt water, only 3% it is fresh water. It is also in the form of here in the form of ice, and only we are getting the fresh water is 0.003% fresh water. So this fresh water is we can take two types are there: surface water, underground water. In surface water, there are again two types are there: standing water, flowing water. So standing water means we can take the example lakes, reservoirs, and flowing water we can take the example rivers, streams. So standing water we can take the example lakes, reservoirs, estuaries. Okay, flowing water we can take the example rivers, streams. So fresh water is two types: surface water, underground water. So the distribution of fresh water, okay, so here it will be different from country to country and from one region to the another region. So we can take surface water now. The water coming through precipitation, nothing but rainfall. The water coming through precipitation, which does not percolate down, into the ground. Means they do not seep, they do not go into the dump. They do not seep into the dump. They do not percolate into the dump. So the water coming through precipitation, which does not percolate down into the ground or does not return to the atmosphere as evaporation or transpiration loss, assumes in the form of lakes, so they will form like in the form of lakes, ponds or wetlands. So all these are known as surface water. So the water which does not percolate in the ground or which does not evaporate as much, so that will be in the form of lakes, ponds or wetlands. So these are called surface water. So the water stored on the surface of water, means which is stored on the surface of the ground, okay, so on the surface of the land, so that is called the surface water. So the surface water is very small portion of fresh water readily available for human use. So the surface water is largely used for irrigation. So we will use water, okay, for cultivation of the crops. We will use the water. We will collect nearby lakes, okay, nearby rivers, okay. We can take nearby the ponds, okay. We will use for irrigation purpose, for cultivation of the crops, and for industrial use, and for public water supply. So for all these needs, we will use the surface water. So underground water. So surface water, what purpose we used? We used mainly for irrigation, for cultivation of the crops, and also for the industrial purpose. Underground water. So this is another type of fresh water. So the water source available deep in the ground due to percolation, means the water which can seep into the down of the ground. So that is called groundwater. So the water source available deep in the ground due to percolation, okay, filtration of liquid through a porous substance, means the substance in the underground, okay. So the water will go through that porous substance, okay. So that water is called underground water. So underground water is the major source of fresh water. So underground water is very pure water in olden days. So our grandfather, means our grandpeople, they drank only well water, groundwater. So groundwater or underground water, it is very purified water. So underground water is the major source of fresh water. It is pure and used for various domestic and industrial purposes. So we can discuss, for taking example, underground water aquifers. These are called aquifers. Aquifers is nothing but a layer of rock, a layer of sediment or rock that is highly permeable. Means in the ground, in the underground, so rocks will be there. So through that rocks, the water percolates, that penetrates, okay, through that rocks, okay, into that rocks, and it will stay there. Okay, so a layer of sediment or rock, sediment means we can take clay or sand. So a layer of sediment or rock that is highly permeable, means it allows water, highly permeable and contains water. So in that, after that rock, okay, so the water where the place is there below that rock, so in that area, in that part, the water will stay. Okay, so that is called aquifer. That part is called aquifer. What is aquifer means? A layer of sediment. It is like a layer of sediment or rock that is highly permeable and contains water. Is called aquifer. So we can see in this diagram aquifer. Okay, so it is forming like a layer. So this is a aquifer. So now we know what is aquifer. Aquifer means it is like a layer of rock that is highly permeable and contains water. Under that rocks, water will be there. So layers of sand and gravels are good aquifers, while clay and crystalline rocks are not. Okay, so when we take, for example, sand layers are there, gravels layers are there, small stones like, so they are like a permeable. They allows the water compared to the crystalline rocks. Crystalline rocks, they do not allow the water. Like a granite. Okay, so they have low permeability. So depends on the rocks formed in the underground. So there are two types are there. Unconfined aquifers, confined aquifers. Unconfined aquifers means unconfined aquifers are overlaid by permeable earth materials. Permeable earth materials means, so we know already, sand, okay, and gravels, okay, permeable earth materials, and they are recharged by water. Seeping down from the above in the form of rainfall and snow melt. So when the snow is melting, okay, in the ground, in the land, in the mountains or somewhere, okay, when the snow is melting or when the rainfall is there, so what happens? Unconfined aquifers means the water, it goes into the ground, in the underground, so through permeable rocks. What is that permeable? What we said, gravels, like a small stones or sand layers. So the water can permeable through that sand layer or small stones layer, and water stays there. So that is called unconfined aquifers. Unconfined aquifers. And what are confined aquifers? Confined aquifers which are sandwiched between two impermeable layers of rock, which are sandwiched. Sandwich means we know. We will take two breads and in the middle we'll keep the vegetable. That is called sandwich. So like that only. So between two rocks, in the middle the water will stay. Okay. So confined aquifers which are sandwiched between the two impermeable layers of rock or sediments and are recharged only in those areas where the aquifer intersects the land surface. Where aquifer intersects the land surface. Where this area where we can see the two rocks are there, in the middle water stays. How it will be staying? So at the end, when it is touching the land surface, so when from there the water comes. So here we can see, in this diagram we can see unconfined aquifer we can see. So when the rainfall, okay, so then confined aquifer, that is between the two layers of the rocks. So this is confined aquifer and this is the unconfined aquifer. So the recharged area in hundreds of kilometers away from the location of the well. See, for example, in Dundigal, we got in our IRE, we got one well we got, okay. But that water, from where it comes, we do not know. Okay. From some kilometers away, maybe in that area, water is there on that land surface or underground, water is there. But this Dundigal area is IRE area, maybe it is with full of rocks underground. But how we are getting the water from the well means, okay, when we are digging the well, we got water. How means from that area, we are taking kilometers, like 20 kilometers away, like that. From that area, the water is coming where the land surface is touching. Okay, so from that area, the water is coming in the underground, and we are getting the water. So aquifers are two types: unconfined aquifers. Okay, confined aquifers. Unconfined aquifers means where when the rainfall comes, where the sand layers, okay, or gravels layer, that will be permeable, means that allows the water and water will stay. Confined aquifers means that is formed in between the two rocks, but that is with low permeability or no permeability, but from where the water comes means from longer distance. So uses of surface and groundwater. So there are two major types of uses of water: consumptive use and non-consumptive use. In consumptive use of water, it is utilized, okay, like domestic, industrial and irrigation. Non-consumptive use means we are using water for hydropower generation, means like producing electricity. So other uses of water we are using for domestic ways. We all know that we are using for washing, cooking, for other needs, okay. And we can take here industrial use. So water is required for various industries. We can take the example: cement, mining industry, textile industry, leather industries, okay. Some other industries also there where we need water, okay. We need water. Without water we cannot do the work, okay. So public use also, we will use the water, okay. In public use also, watering the park, okay, flushing streets, okay. And next, fire use. Water is used in case of any accidents are there, okay, any fire issues are there. And irrigation, to grow the crops. So this is the main source for the food, okay. So we have to use the water for the irrigation purpose. So other uses, already I said that we will use for hydroelectric power generation. So that requires water to produce electricity. So what are the effects of groundwater usage? So now we are not getting a groundwater. We are not getting here bore water. Okay. So after using that bore water for 2 years, after that we are not getting the water. Why? Where the water gone? Okay. So how the water we are not using water means we are not getting the water nowadays means what are the effect of groundwater usage? Okay, so the first effect is subsidence. The first effect is subsidence. You can see here how the subsidence, how ground subsidence is taking place here. Okay, when the groundwater withdrawal is more, when we are using more groundwater than its recharge rate, the sediments in the aquifer get compacted. Okay, and a phenomenon, it is known as ground subsidence. Okay, our sediments in the aquifer, they compact, they shrink like compacted, and this is known as ground subsidence. So huge economic loss may occur due to this phenomenon because it results in the sinking of overlying land surface. So we can see how this land is sinking here in the diagram. We can see, okay, ground subsidence. So the common problems here, what we can see, damage in buildings, fracture in pipes is taking place, damage in buildings, sometimes buildings also it will collapse, fracture in pipes will be taking place. Okay, so reversing the flow of like a canals. Okay, and sometimes it leads to flooding also. So all these effects will be there when we are overutilizing of the groundwater. So second one is lowering of water table. This is most important, lowering of water table. So in the diagram we can see very clearly. So before heavy pumping and after heavy pumping. So in the diagram we can see very clearly before heavy pumping. So the water table we can see. So the water table we can see before heavy pumping and after utilizing the water frequently. So lowering the water table we can observe in the diagram. So mining of groundwater is done extensively, okay, in regions, and also for irrigation of crop fields, okay. So when they are using more water, like for irrigation purpose, for cultivation of crops, okay, for industrial purpose, so we can see lowering of water table is taking place. So it is not advisable to do excessive mining. So mining we should not go for, okay, doing that process, more mining process and more here irrigation we can do, but we cannot utilize more water. So how much we need, that much water we have to utilize. So it will cause here what happens, it would cause a sharp decline in future agricultural production due to lowering of water table. So what happens when the lowering of water table is taking place? Our future generation, they do not get water for agriculture. They do not cultivate crops. Okay, so water is declining, means it is decreasing, lowering of water table. So we should not utilize more water. And third one is water logging. So when excessive irrigation is done, when we are using more water, okay, when we are using more water for irrigation purpose, okay, with brackish water, means nothing but salt water, it raises the water table. So before what we discussed point is lowering the water table. But here when excessive irrigation is done with brackish water, with salt water, it raises the water table, it increases the water table. So gradually it leads to water logging. Water logging, nothing but it is with the surface of the land, okay, it is with full of water. And sometimes it leads to the salinity problems. Okay, so we can see effect of water logging: inhibiting activity of soil bacteria, decrease in available capillary water, falls in soil temperature, and defective air circulation, and rise of salt. Okay, see salt concentration, percentage of the salt concentration is increasing. So one of the good point is defective air circulation. When water is more in the soil, there won't be there won't be air circulation. So air circulation is important for the plants, okay, in the soil also. So the bacteria should live, okay. So inhibiting activity of soil bacteria. So this is also one good point. So water logging also, it will be there, okay, when we are using more water for irrigation purpose. So we discussed now, okay, what are the points we discussed now? Overutilization of surface and groundwater. So it leads to the shrinkage of the sediments. It leads to the ground subsidence. It leads to the ground subsidence, and we discussed that here ground subsidence after leading, and sometimes what happens, collapsing of buildings will be taking place, and it leads to the earthquake. It leads to the earthquake. In this diagram we can see very clearly. So when earthquake it comes, and here collapsing of buildings will be taking place. Okay, so when we are utilizing the water, groundwater or surface water more, it leads to the earthquake and ground subsidence. Leads to the collapsing of the buildings. Okay, and overutilization of groundwater in coastal areas leads to the rapid instruction of salt water from the sea. So thereby it is not suitable for agricultural purpose and drinking purpose. So we should not use the salt water also more. When we are using that salt water for cultivation of the crops, so the soil fertility also decreases. So that soil, cultivation of the crops, that soil we can use for about 5 years. After that 5 years, it is full of with salt. That is covered with full of salt. So again, we cannot cultivate plants there in that land, in that fertile land. Means soil fertility decreased, and where the concentration of the salt is more because of the utilizing the salt water. Utilizing the salt water for the cultivation of the crops. So all these here we are getting the effects. We are getting the effects because we are using the water more, like a salt water we are using and groundwater we are using. Okay. And overutilization of groundwater, it leads to drying up of dug wells as well as bore wells. So previously I told bore wells, it is drying up because of overutilization of the groundwater. So overutilization near agriculture land decreases the water level. The surface water containing fertilizers, pesticides and animal waste containing nitrate, it percolates rapidly into the ground because we are using fertilizers, pesticides. So it will go into the ground through rainfall and pollute the groundwater. So when this nitrate concentration is like a 45 milligram per liter, so the water becomes unsuitable for drinking. Unsuitable for drinking. Now, next is we have to discuss about floods. Okay. So when the overflow of water is there, it leads to the flood. It leads to the flood. So an overflow of water, whenever the magnitude of water flow exceeds the carrying capacity of channel within its banks, it is called a flood. Okay. So what are the causes of flood? What are the causes of flood? So we heard that in China, we got previously, past 2 years, we got floods in China and Kerala. Okay. So what are the causes of floods? So various causes of floods are because of heavy rainfall and sudden melting of ice, insufficient water channel capacity of rivers, and because of the construction of the buildings and roads, which prevents infiltration of water into the soil. And also deforestation. We are cutting the trees, we are cutting the plants, deforestation. Overgrazing. Overgrazing means we are cultivating more animals, like they are eating the grass. Overgrazing. And mining increases the runoff from the rains and hence increasing the flood level. All this leads to the flood because of the heavy rainfall, melting of ice, then construction of buildings and roads, deforestation, overgrazing and mining. All these increasing what? Floods. It leads to the flood. Soil erosion and the loss of vegetation would leads to the flooding due to heavy rain. Okay. So here what happens when floods will be there? It leads to the soil erosion and loss of the vegetation. So now what are the effects? In this diagram we can see when the floods comes, say one huge building that is collapsing. We can see when flood comes, one huge building is collapsing and people are suffering to go from that area to the another area. So flood water brings various diseases and it kills human lives. Okay. So aquatic and wildlife habitats are destroyed by floods. and aquatic life means like fishes, okay, and other wildlife also. So that will be destroyed by floods. So this leads to loss of biodiversity due to migration of wildlife species to the other areas. So when the flood comes in one area, from that area, that wildlife, the wild animals, okay, it will go from one area to another area. Okay, some animals will die. Okay, so this is also here it leads to, we can see, because of the floods, so loss of the here biodiversity. So flood causes economic loss, loss of the crops, loss of the livestock, and property damage. So drainage system and public transport system get disrupted, causing inconvenience and discomfort to common public. So floods can cause here damage to bridges and damage of hydropower plants. So agricultural produce can be submerged under flood water, causing financial loss to community. So because of the floods, so there are so many effects are there. So many effects are there for taking like a plants or like agriculture or animals or human beings, health of the human beings. So everywhere here there will be loss of loss will be there for the environment, means human beings. So we can see in these diagrams how people are going from one area to another area. So during floods time, so we can see and how this crops, the damage of the crops here, and collapsing of buildings because of the floods. So how flood management we can do is construction of dams and reservoirs is an effective method of controlling floods. So we have to construct the dams. When we are constructing the dams, we can store the water. So advanced meteorological information can give enough time to active disaster management systems. So when floods comes before that, okay, so we have to get the information, so the people can go from one area to another area and they can save themselves. Okay, so we can do that. Hydro engineering operations in flood affected areas for proper diversion of flood water. So they have to take proper operations, and construction of floodways and reserving green zone on the river banks. So they have to go for again construction of that floodways and reserving green zone on the river banks, means cultivation of the plants. Now next is droughts. So it is very important, droughts also. Drought means scarcity of water. When there is no water, that area it is called a drought. Okay, so drought occur due to inadequate rainfall. When the rainfall is not there, that leads to drought. That area is called a drought area. Okay, so because of here, when there won't be no rainfall, when we go for desertification, when we are cutting the trees, okay, so there won't be rainfall. So that area becomes drought. When we are going for here overutilization of groundwater, sometimes that is also leading to the here it leads to the drought. So that the conditions of dryness for prolonged period, not like months, not like 6 months, 1 year. It is like a prolonged period, like 5 years, 10 years, 20 years. Okay, so the condition of dryness for a prolonged period is called drought due to drop of average rainfall. When there is no rain there in that area completely, so that area becomes a drought. So drought cause famine and starvation of human and animal population of region concerned. It leads to famine and starvation. There won't be in that area, no food will be there. So we will see South Africa, people are suffering to get the food, enough food. So they will take a 2 day, in a day they will eat only 2 times. 1 time only they will eat because of the scarcity of water, because they do not have proper cultivation of the land. So shortage of water for even the basic needs is the main problem in the drought areas. Okay, shallow rooted plants, they do not grow in that area, and infiltration wells will be there, and construction of dams and watersheds. So here in that area, so what we can do means construction of dams. Okay, we can construct dams, we can store the water, and cloud seeing techniques, we can go in that area. See, we can do artificial rain. We can form clouds artificially. So we have to throw that sand will be there. We have to throw the sand in the sky. Artificial rain we will get. Okay. Cloud seeding techniques, artificial rains, all these to be implemented in that areas. So then there won't be any drought. Okay. So in that area, no drought. So what we have to do? We have to go for artificial rain. Now, in drought, what are the damages means? Directly damages are there, indirect damages are there. So direct damages means loss of income, social dislocation. Nobody will live in that area. Okay, no people will be there in that area. No animals will be there. Okay, so famine and death of the people, death of the animals. Indirect means loss of the rural and urban revenues and fire hazards and loss of the water access. Now, third part is in water resources, we discussed floods, droughts, and last part is the benefits of dams and problems. What are the benefits of dams? We are constructing the dams, but some benefits will be there. Okay, some problems also will be there. So the construction of dams have their own benefits and drawbacks. So dams are built for storing water. Okay, now Nagarjuna Sagar Dam is there. Okay, so constructing that dam, we need a large area. Okay, loss of vegetation is there. So loss of the animals when they have constructed the dam. But what is the benefit? So that water we are utilizing for cultivation. Okay, so dams are built for storing water. The stored water it is used for irrigation, hydroelectric power generation, and flood control. For producing electricity, for flood control, and for cultivation of the crops, we are utilizing the dams. So what are the benefits of dams? So here the river valley projects with big dams have usually been considered to play a key role in the development process due to their multiple uses. So India has the distinction of having a largest number of river valley projects. So in India we have largest number of river valley projects. So the tribals living in the area, they have big hopes on these projects. Okay, because they can lead to life. Okay, means they can go for cultivation of the crops. Okay, and they will get the food. Okay, so the tribals, they will have a big hope because of the projects, construction of the dams in the nearby the rivers, or we can take the lakes. Okay, the dams have tremendous potential for economic upliftment and growth. So they can help in checking floods and famines, generate electricity and reduce water and power shortage, provide irrigation means water to cultivated areas for cultivation of the plants. So where the area they are not getting the water means we can give the water to them for the cultivation purpose, and we can provide drinking water also in remote areas. Okay, and we can promote navigation and fishery, so etc. All these are benefits when we are constructing the dams. So we can see in the diagram the dams. So where we can store the water, so that water we can use for irrigation purpose and for other needs, for producing electricity, and here for drinking purpose also in remote areas. So we know now in a simple way we understood that dams are built for generating electricity, for irrigation of agriculture, and for drinking water for the community remote areas. And dams can store here flood water, thereby control of flood threat. Okay, so it can dams have saved countless millions of lives from floods. So dams can divert flow of water from river into here we can take an channel. Drought control, we can control the drought also, means the areas who are not getting the water, we can provide the water for the cultivation of the plants. So what are the problems are there? When we are constructing the dams? Okay, so the upstream problems are there. Displacement of tribal people. The tribal people, they have to go from one area to another area. Okay, so when construction of dams is there, so loss of forest and flora and fauna, plants and animals. So changes in fisheries and spawning grounds, and siltation and sedimentation of reservoirs, and loss of non-forest land also, and here water logging near reservoir, and where water logging will be there near reservoir, more water stays there only. So breeding of vectors and spread of vector-borne diseases in that area where the water is stored, there will be more microorganisms will be there, that leads to the vector-borne diseases. Okay, so reservoir induced seismicity causing earthquakes. Okay, because when we are constructing the dams, when we are digging that land, sometimes it leads to the earthquakes also. Okay, so all these are here upstream problems when we are constructing the dams. And downstream problems are there, water logging. Okay, already we discussed water logging, here also it comes, and salinity due to over irrigation. Okay, so next reduced water flow and flash floods and salt water intrusion at river mouth. So at river, near the river, more salt water will be staying, more concentration of the salt water, and loss of land fertility along the river since the sediments carrying nutrients gets deposited in the reservoir. So when we are constructing the dam, so the land nearby the river, that land where we can lose the soil fertility. And outbreak of vector-borne diseases like malaria, okay, increasing the disease like malaria. So here, but although means we are knowing some disadvantages or problems of dams, but there will be many advantages are there for the people, for the irrigation purpose. For the remote areas, we can give the water and for drinking purpose or producing electricity. So the dams are built to serve the society with multiple uses, but it has several serious side effects. Even though side effects are there, but there are advantages are there. So that's why what we are doing now, there is a shift towards construction of small dams or mini hydel projects. So what people are planning now is not constructing a large dams or big dams. So they want to construct a small dams or mini hydel projects because only small area will be occupied. So now we know what are the problems in construction of the dams. It harms the environment, and here it will dams fill with the sediment, and here what soil fertility it will be decreases, and dams can be unsafe and have killed thousands of people, and here several constructing dam, it results in displacement of several villages, communities, and loss of agriculture, and deforestation can lose the habitat and loss of biodiversity. So it will leads to environmental degradation. So some problems are there. So it leads to environmental degradation also, loss of the habitat will be there, and loss of biodiversity, and several villages they have to shift from one area to another area. Okay, loss of agricultural land will be there. So all these here we have problems. We have the problems on constructing dams. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.